अस्सलाम वालेकुम सर। अस्सलाम वालेकुम रेहाम।
वालेकुम अस्सलाम।
अच्छा चलें, अच्छा हुआ आप आ गई। मैं असल में एक बड़ी नॉइजी जगह पे हूँ इस वक्त, और फिर मुझे यही अप्रोप्रिएट लगा कि मैं यहीं से मीटिंग इनिशिएट कर देता हूँ। बट जैसे हमने डिसाइड किया था कि फिर आपको ही ज़्यादा मॉडरेट करना पड़ेगा,
यस सर।
तो मैं बस एक मैसेज ग्रुप पे कर देता हूँ सो दैट सब लोग आ जाएं।
सर आई हैव टू डिसाइड टुडे कि प्रेजेंटेशंस का ऑर्डर क्या होगा, राइट? ऑन द एक्चुअल डे हमारा बेस्ट सॉल्यूशन क्या है?
सो अभी मतलब देखिए, तभी हमने थोड़ा सा डेडलाइन कल की रखी है ना, ताकि आप लोग कल सोल्यूशन सबमिट कर दें, तो फिर सज्जाद और मैं भी सोल्यूशंस को रिव्यू कर लेंगे। तो
ओके सर।
मैं एक मिनट अभी इनको कहता हूँ ना कि स्टार्ट तो करें सारे।
ओके सर।
सो रेहाम, मेरे ख्याल से हम लोग फिर स्टार्ट कर लेते हैं रायान से।
यस सर, लेट्स डू दैट।
हम सर, असल में मैं अभी फोन पे हूँ। मेरी जो प्रेजेंटेशन है वो प्लीज जरा सा बाद में रखते हैं।
अच्छा, फिर चलें हम थोड़ा सा और वेट करते हैं कि एटलीस्ट हाफ ऑफ द पार्टिसिपेंट्स तो मौजूद हों।
यस सर, लेट्स जस्ट वेट फॉर एवरीवन।
तो रायान, जो आप सवाल सुबह पूछ रहे थे, उनके कोई आपको मिले जवाब?
जी सर, वो मैं खुद देख लिया था।
सही है, अच्छी बात
पहले
है। वैसे कि लेट्स सी के सजाद की तबीयत थोड़ी ठीक हो, तो कल का दिन है, हो सकता है वो कल रिस्पॉन्ड कर जाए।
जी सही, वो
Ryan, I
एक
have
पहला
one.
तो मैंने क्लैरिफाई कर लिया।
Yeah.
जी
Ryan,
रेहाम,
I
आप
have one
बोलिए।
question.
जी
Is your question complete? Yes, पूरा question हो चुका है, like सारे parts के साथ?
पार्ट सारे हो चुके हैं, उन पार्ट्स के अंदर जो सब पार्ट्स हैं ना, उनमें से
जी।
एक बताते हैं। वो ही मैं पूछ
अच्छा
रहा था सर से ज्यादा सर।
ठीक, क्योंकि मेरा जो मेन क्वेश्चन है ना, क्वेश्चन 7 जिसको मैं सबमिट करवाना है हमें, उसका मेरा एक बहुत बड़ा मेन पार्ट रह गया है और वो मुझसे सॉल्व ही नहीं हो रहा है। मैंने सर से जांच भी बोला था, वो पहले जब बीमार थोड़े कम थे जैसे, तो उसको मदद कर रहे थे लेकिन उनको भी नहीं मिल पाया। और फिर मैंने हाशिम से भी मदद मांगी, ग्रुप पे भी मदद मांगी, और किसी को समझ नहीं आ रहा है कि प्राइमरिटी टेस्ट क्या मिलेगा जिसको मैट्रिक्स में डाल सकते हैं। तो मैं बस ये बोल रही थी कि हमें 6 सम्स देना बहुत सख्त जरूरी है। तो अगर किसी के क्वेश्चन जिसके हो रहे हैं, वो इस वाले क्वेश्चन में मदद कर दी, क्योंकि ये तो मुझे लेट मिला था थोड़ा, तो इसलिए इसमें देर लग रही है थोड़ी और मुश्किल बहुत है।
चलें, यस मैं ये भी अपना भी साथ साथ कर रहा हूँ, मैं वो भी देख लेता हूँ। क्वेश्चन 7
या
कौन सा पार्ट है क्वेश्चन 7 का?
पार्ट 5।
ओके।
रेहाम, इसमें मैं भी उसकी स्टेटमेंट रीड कर रहा था। एक तो उसमें
जी
ये बात है कि n=1 के लिए जो है वो ये कह रहे हैं कि फर्मास थ्योरम जो है वो n=1 के लिए है।
यस सर, वो बात ये है कि उन्होंने हमें क्वेश्चन में ये भी बोल दिया है ना कि फर्मा थ्योरम के अलावा कुछ इस्तेमाल करना है, तो उसकी वजह से मैं जितने भी
इसमें
टेस्ट ढूंढती हूँ वो सारे फर्मा से लिंक हो जाते हैं। मुझे एक मिला जो मैंने ग्रुप पे
n
भेजा
का
था। जी सर।
n का कोई रोल है ना, कि अगर n=2 के लिए शायद फर्मास थ्योरम नहीं है एप्लीकेबल, और वो n=2 पे कह रहे हैं कि आप n=2 के लिए कोई और टेस्ट तलाश करें।
हम्म, श्योर दैट कुड बी है, तो बात ये वो भी नहीं मिल रहा ना। मुझे एक चीज मिली है कि फॉर एक्स वाई को प्राइम टू पी, फिर वो एक फॉर्मूला है x प्लस वाई टू द पावर ऑफ p को इज कॉन्ग्रुएंट टू x टू द पावर ऑफ p प्लस y टू द पावर ऑफ p विद मॉड p। मुझे वो मिला था, मुझे बस कंफ्यूजन ये हो रही है कि इसको मैं मैट्रिक्स के फॉर्म में कैसे लाऊंगी और इसको प्राइमरी टेस्ट मैट्रिक्स का कैसे बनाऊंगी, क्योंकि मुझे उसमें बहुत मुश्किल हो रही है कि जनरलाइज कैसे करूँ मैं।
अच्छा, एक तो उसमें बात जो आप वो करें, देखिए 6 सम्स तो हमारे उस तरह से हो गए हैं कि ये एक पार्ट नहीं हुआ, बाकी तो सारा पार्ट्स आपने किए हैं उसमें।
बट सर
तो
पार्ट 2 भी रहता है, पार्ट 2 और 5 ये दोनों रहते हैं, बाकी 4 पार्ट्स हो गए, इसके 6 पार्ट्स थे इस सवाल के। तो
चलिए,
मैंने
मतलब
हम्म
सोल्यूशन तो है हमारे पास। तो
या सर।
लेकिन, अभी हम यही दुआ ही कर सकते हैं कि सर सज्जाद की तबीयत जरा कल ठीक हो, ताकि जो
जी
कल लास्ट डे है तो
जी
हम थोड़ा एफर्ट करते हैं। और असल में डेडलाइन हमने कल की इसी वजह से रखी थी, जैसे मैंने आपको बताया
जी
कि फिर
सर।
हमारे पास फिर सर सज्जाद और मैं थोड़ा सा कोशिश करते रिव्यू करें। सो
जी
लेकिन अभी इट्स गेटिंग लेट, तो हम स्टार्ट करते हैं। सो अब्दुल्ला, आपसे फिर स्टार्ट कर लें हम प्रेजेंटेशंस। मोहम्मद।
अब्दुल्ला।
अस्सलाम वालेकुम सर। अगर पॉसिबल मैं कर तो देता हूँ अभी, लेकिन अगर पॉसिबल है तो मैं जैसे कोई 10 मिनट में दे सकता हूँ, क्योंकि नेट अभी रीस्टार्ट करना है, वो लैग कर रहा है।
आप फिर हाँ, आप रेडी हैं फिर?
हम्म।
क्योंकि रेहाम फिर आप ही बचती हैं, आपसे फिर स्टार्ट कर लेते हैं।
सर मैंने अपनी प्रेजेंटेशन तो कल ही दिया है, मैं क्या फिर से दे दूं?
जी जी, अच्छी बात है। देखिए, आपकी एक रिहर्सल हो जाएगी।
अच्छा ठीक है सर, मैं आप मुझे फिर से दे दें, मैं जरा लिंक लोड कर दूं।
ठीक है, फिर हम आपसे स्टार्ट करें और उसके बाद फिर आप मॉडरेट करें।
सर मेरी स्क्रीन शेयर हो रही है?
जी हाँ, हो गई है स्क्रीन शेयर। और बस आपके प्रेजेंटेशन के स्टार्ट से पहले मैं बस आपको ये बताना चाह रहा हूँ कि अब जैसे ये सिचुएशन है ना कि हमने पार्शल सॉल्व किया है, तो
जी
कोशिश करते हैं कि कल में कुछ वो हो जाए जो पार्ट्स रह गए हैं। लेकिन अदरवाइज आप अप्रोच फिर ये रखें ना कि जो आपने किए हैं ना उनको इतना परफेक्ट, मतलब उनकी प्रेजेंटेशन और उनकी लेटेक्स पे मैथमेटिकल राइटिंग, वो
जी
सारी चीजें परफेक्ट हो कि मतलब जो ज्यूरी देखे उसको वो इतने पसंद आए कि दे कांट इग्नोर इट, कि चलो है पार्शियल सोल्यूशन है लेकिन जो है वो बड़ा जबरदस्त होना चाहिए।
ओके सर।
सो चले आप करें, फिर स्टार्ट करें।
ओके, बेसिकली अस्सलाम वालेकुम एवरीवन। प्रॉब्लम 7 पे मैं काम कर रही थी। प्रॉब्लम 7 का पार्ट 1 states that k and n are positive integers and n by n is a matrix with integer entries. And they've given us the polynomial f a k x with equals to determinant of a to the power of k minus xi minus determinant of a minus xi. I here stands for the identity matrix and the determinant is the determinant of the matrix, where that's what it is. And the question asks us that we have to prove that k is prime for all coefficients, and for all of the coefficients of f, a, k, x, they're all divisible by k, which is prime. So first, what we're going to try to do is reduce this expression into a polynomial. And we're going to use that by the equation determinant of a plus b equals to determinant of a plus determinant of b plus trace a trace b minus trace a. And a and b are n by n square matrices. So furthermore, we're going to use the identities of determinants and traces to simplify this equation above. So we have determinant of CA equals to Cn, determinant of A, trace CA equals to C trace A, and trace AB equals to trace of B. And C is a scalar constant. Now that we have all our equations and identities, we're going to try solving the polynomial and make it into a linear equation. So here we have it, and we've simplified it by as given in the equation above. And all of this simplifies to a linear polynomial. That means that the question, since it's asked us for the coefficient being divisible by k, we're going to ignore everything except for the coefficient, which is trace ak minus trace a multiplied by 1 minus n. Now that we have that, we have to prove that when k is prime, k is trace ak minus trace a, and this can be written as a modular congruency. So trace of ak minus trace a is congruent to 0, and trace of ak is congruent to trace a mod k. And since this is all, this part specifically has already been proven by V.I. Arnold, which link I have provided in the following in the solution. So therefore the proof is complete. Now moving on to part 3, they've given us this equation where they've already told us that we have to assume that n is equals to 2. And now we have to consider the factorization of this equation that they've given us, where k equals to this, into primes. Now, the equation they gave us is gk equals to half of this and hk equals to half of big pi with the limits of I equals to 1 and s. What we have to prove is that for a and k of all coefficients, this equation, determinant of ak minus xi minus determinant of a k minus 2hk minus xi, if it's all the coefficients are divisible by k. So either we have to provide a proof or a counter example, and that's what I've done below. Basically, what we started off with finding is that hk, the equation that they gave us, is actually related to Euler's torsion function, and it's equal to this. So Euler's torsion function is actually equal to big pi with the limits of I equals to 1 to s, and pi alpha I minus 1, pi minus 1, where k's representation is this. And looking at the definition of hk, it was clear that hk is phi k half, right? So this would be useful in the problem because now that we have determinant of ak minus 2hk minus xi, which is equal to a determinant of ak minus phi k minus xi, and that's going to be important later. Now, continuing with this, we're going to use a similar simplification method that we did in part 1 using the equation that we had. But now we're going to be using it with this expression. Last time we had a and a to the power of k. Now we have a to the power of k and a to the power of k minus 5k. So we're going to do the same steps as we did last time and use the same identities. And this time we're going to end up with the equation of trace ak minus trace ak minus 5k into 1 minus nx plus determinant of ak minus determinant of k minus 5k of k. And in this case, we have to remember that n is 2, but for as of now, we don't really mind that because it's not as necessary for the solution. And if k is trace k a of ak minus trace ak minus 5k for all the valid values of k and a, then the statement in the question is true. Now that we have this, we're going to be rewriting the modular congruency. So we have trace of ak is congruent to trace of ak minus 5k. But this time, it's important to remember that like it did in part 1, this is the opposite where the congruency does not always hold. So an example of this is when the setting of A is 0, 1, minus 1, 0, which is a rotational matrix of in the Cartesian plane. And when we take the value of k, when you arrive at these values, the result is 4, which is congruent to 2, which is not congruent to 2 mod 6. It is important to remember that the concept of mod is that the remainder is equal to the number that you've taken the remainder of. And 4 is not congruent to 2 mod 6. With this counterexample, it is clear that the statement given in the question is false. So we've provided a counterexample rather than a proof, which is asked for. Moving on to part B of this question. It asks us that if a and k of all coefficients with a new expression this time, which is determinant of a to the power of gk plus hk minus xi minus determinant of a to the power of gk minus hk minus xi. And if its coefficients are divisible by k. Once again, proof or counterexample. So what we're going to do this time is we're going to use the fact that there's a characteristic polynomial for a 2 by 2 matrix, and that is z square minus z trace a plus determinant of a. And looking at the question, we can reduce the problem in a similar way and arrive at the congruency of trace a to the power of gk plus hk, which is congruent to a to the power of gk minus hk mod k. Now this we have to either prove or disapprove of, right? So we'll say that let this equal to gk plus hk equals to half of the equation that they've given. And we now have that a to the power of jk plus hk is, and a to the power of jk minus hk is equals to a to the power of k minus 5k. As proven into the characteristic polynomials of this is a to the power of k and a to the power of k minus 5k, which will be congruent to mod k. Okay, z square minus z trace of a k is congruent to z square minus z trace of a k minus 5k plus determinant of trace a k minus 5k, which is mod k. Now we have z square on either side of the congruency, so we can cancel that out as we can in a normal equation. And furthermore, we're going to substitute z as 0 to further simplify this equation in determinant of big phi k, which is congruent to determinant of big phi k minus phi k mod k. So since these are congruent as well, they will be cancelled out. Finally, we're going to be substituting z to the power of minus 1. Wait, I'm sorry. Z to the power of minus 1, it's easier to cancel it out and simplify this equation because it helps us go to the purpose, which is that we need to simplify this into a simple equation to prove or disprove of the first of statement. When we plugged in z to the power of z equals to 0 first, we simplified it, and then it made sense to simplify it by using 0 equals to minus 1. And then the congruency will yield trace to the power of a to the power of big k, phi k, which is congruent to trace to the power trace of a to the power of big phi k minus phi k mod k. And thus we have proven this statement to be true. Now, once again, we're going to be either proving or disproving the statement using modular congruency, which is trace with a to the power of k is congruent to trace to the power of k minus phi k. And this time they've said that A is a 3 by 3 matrix as given by the question that n is equals to 3. Thus, it's a 3 by 3 matrix. The setting of A is 1 0 0 0 0 minus 1 0 1 0, which is also a rotational matrix in the Cartesian plane. And we will once again try with case 6 and arrive at an invalid result of 5, which is not congruent to 3 mod 6. Once again, since we found a counterexample, we've disproved the statement and provided with the counterexample that they wanted. And these are the further links given to us for the proofs that I've provided and all. Thank you.
Right, रेहाम, आई थिंक कल से इम्प्रूव्ड थी इन द सेंस कि आपने हमारे वो फीडबैक को किया था इनकॉर्पोरेट, सो वेरी गुड. तो अब फिर आप ही डिसाइड करें हु गोज नेक्स्ट, और आपने फिर उसमें ध्यान रखना है कि जो 10 मिनट लिमिट है उसको कोई एक्सीड ना करे.
Okay, sir. Wait. Okay, let's start with Rayan. Are you free now?
Yes, give me a minute. मैं screen share करता हूँ.
Okay. So we'll start with Rayan, and then after that, once he's done, we'll go with Abdullah, Mohammed Abdullah. Then we'll go with Hashim, and then we'll go with Abdullah. Shaibanu isn't here yet. I'll just ask her on the group to join.
सो एवरीवन, जो रेहाम ने ऑर्डर बताया है, सो उस ऑर्डर पे आप लोग इमीडिएटली जो है करें, फिर प्रेजेंट करें.
Is my screen visible?
Yeah, you can start.
Okay, so problem number 6, Diophantine equations. So the abstract for this question would be that this question basically focuses on Diophantine equations, more specifically the Mordell equation, which is named after Louis Mordell, who conducted extensive research on this equation during his lifetime. The solutions to this problem would include looking at multiple theorems, including Haas's theorem for the first part, using pre-solved integral solutions to find out the integral values of a and b in the second part, and utilizing the elliptic curve formed by Mordell's equation in the third part. Okay, now let's move on to part 1. In part 1 of the question, we are given a Diophantine equation in congruence to modulo a number n, which we can take to be a prime, which is congruent to 3 modulo 3, which is congruent to modulo 3. The equation is given as y is congruent to x cubed plus m mod n, where m and n, which is greater than or equal to 2, are given integers. For this question, we have to prove that the value of m does not affect the number of solutions x and y, which are a subset of zn x zn. One thing to note is that the question is not asking us to prove that the solutions have to be the same for every value of m, but to prove that the number of solutions has to stay the same for every value of m. Now, the first way we can tackle this problem is by using the Legendre symbol. Okay, the Legendre symbol is basically a function that helps us know whether or not a number is a quadratic residue modulo an odd prime. It is declinated by it basically looks like a fraction a over p, and it basically gives us 3 return values. If it's a 1, then it means that a is a quadratic residue modulo p, and a is not equal to or congruent to 0 mod p. If our answer is a -1, a is a quadratic non-residue modulo p, and if our answer is a 0, then a is congruent to 0 mod p. Now, in terms of this question, we can take the value of n to be any prime, which is congruent to 2 modulo 3 as they ask in the question. So basically, our value of p, as denoted up here, would be n. And then we can take the values in the set Zn, which would go from 0 to n minus 1 for each case. So basically, we'll take 5 different cases. In our example, like if we take n to be 5, we'll take 5 different cases where our Legendre symbol would basically be 0 over 5, 1 over 5, 2 over 5, up until 4 over 5. Okay. Now, that would give us the answer. For 0 over 5, we'll have 0, 1 over 5, we'll have 1, -1, and 1 respectively. And now basically it shows that we have two squares, basically two quadratic residues. Now, when we change the value of m, it doesn't really change the number of quadratic residues, but it only displaces them. So for example, if our value of m is, let's say, 1, okay, so it will just displace our values in the sense that our order is 0, 1, -1, -1, and 1. Then our order will be 1, 0, 1, -1, -1. So our number of quadratic residues for these cases does not change, hence proving our solution. Another we can look at this is a trial and error method. We basically take the value of m to be n, which would satisfy the condition given in the question. You already know that the values of Zn is 0 to n minus 1. So z2x z2 would give us four possible answers: 0, 0, 0, 1, 1, 0, and 1, 1. And considering that m modulo 2 can only give us two possible answers, we would have two possible equations: y is congruent to x modulo 2 and y is congruent to x plus 1 modulo 2. When we plug the answers we found earlier, we can see that 0, 0, and 1, 1 satisfy the first equation, and 0, 1, and 1, 0 satisfy the second equation, basically showing that our answers change, but the number of our answers doesn't change. Hence, again, proving the statement in the question. Now let's move on to part 2. Now, part 2 is asking us to find all integral solutions for a and b, for which the equation y square is equal to kb plus kb square is equal to x cube plus a cube, for which would have no integral solutions. The question has given us different conditions to find the integral values of a and b. So these different conditions are basically different values of k is equal to 0, 1, 2, and -2. Now, for our first condition, when k is equal to 0, we can ignore b, as k is a coefficient of b, and when k is equal to 0, our value of b does not matter. Our equation would be y square is equal to x cube plus a cube. So basically with this, we would have 0 is equal to x cube plus a cube if we assume the value of y is 0. Let's first of all, for the sake of the question, assume that the value of y is 0. So this would manipulate to be minus a cube is equal to x cube. So minus a is equal to x. Now, this tells us that there will always be a non-zero integral value to the equation when y is 0, where the value of x is the value of minus a. So our answer for the first condition would be that there are no values of a and b, for which there are no integral values to the solution. Now, for condition 2 to 4, we would take pre-found values of the Mordell equation found online. The first condition, we would get y squared plus b squared is equal to x cube plus a cube. Let's write the equation as y square is equal to x cube plus n, where n would be a cube minus b square. For condition 2, we can use the value of n to be 7 and 11, for which we would get our answer to be 2, 1, and 3, 4, which would be our answer for the second condition. Now, for condition 3, we would have n to be equal to a cube minus 2b square, and we will use the values of n to be 7, 14, and 23, and our values would be 2, 1, 4, 5, and 3, 2. And for the fourth condition, we will have our value of n to be a cube plus 2b square. Our values of n would be -6 and -14, and our answers would be -3, 1, and -4, 5. And let's move on to part 3. Our first part consists of two Diophantine equations, the two being as shown. The first one is a general Diophantine equation, which we would solve by factorizing or considering the products of the factors. And the second equation is called the Mordell equation. The specific Mordell equation has already been solved, but I will explain how to solve it further on. Now, we can factorize the equation as follows, and we would get x minus y multiplied by x minus y whole square plus 6xy is equal to 1. Now, we can take our values of x minus y and the second equation. We can basically make two different equations. X minus y is equal to 1 and x minus y whole square plus 6xy is equal to 1. We can do the same by taking each value instead of 1 to be -1, and our answers would be similar. Solving these two equations simultaneously, we would get the answers 1, 0, and 0, -1, which would be our answers to the first equation. Now, for equation number 2, the equation in the form y square is equal to x cube plus k, where k is an integer, is called Mordell's equation due to his extensive research on the equation. Basically, this equation has a limited number of finite solutions, of integral solutions, but an infinite number of rational solutions. So this question can be answered using Mordell's curve, which is a unique type of elliptic curve formed by the Mordell equation. where all the integral points that lie on the curve are integral solutions to the equation y squared is equal to x cubed minus 7. The initial solution to the equation can be found using pure intuition or trial and error, let's say, and the answer would be 2 comma 1. When we plug in values from minus 10 to 10, we can find out that this would be the only integral solution. So now to find other points that lie on the curve, we would basically use the addition theorem for elliptic curves, which basically states that when we find the tangent of a point on the curve, then where that tangent intersects the next part of the curve, we would find our other answer. So our tangent at this point of the curve would be y is equal to 6x minus 11. We would find this by derivating the equation given here and by plugging in the values 2 comma 1. This would be the way we would find the tangent. And now when you plug in the tangent, when we plot the tangent with the elliptic curve, we find that we get another integral point, and that point is 32 comma 181. Say. So now these are the two different answers, 2 comma 1 and 32 comma 181. Now because elliptic curves are reflections of each other, basically they reflect on the x-axis, are we will actually have four answers, 2 comma plus minus 1 and 32 comma plus minus 181. So those four answers would be our answers to the third part. And yes, that concludes my presentation.
अच्छा अब्दुल सॉरी रायान, एक तो ये कि आपने कहीं पे डेरिवेटिंग बोला था, तो ये डिफरेंशिएटिंग होता है, ठीक है?
ओके
और आपकी जो स्लाइड 6 है ना, उसमें सर सज्जाद ने आपको एक बहुत अच्छा मशवरा दिया था कि आपकी जो इक्वेशंस वो फटी हुई आई हैं ना थोड़ी सी, तो
सज्जाद ने मुझे वो मशवरा दिया था ना, वो मैंने ये यहाँ ऐड कर दिया है।
नहीं, स्लाइड 6 पे एक चीज जो आपकी है, स्लाइड 6 पे एक लाइन बहुत अगली हुई हुई है, ये देखिए ना, गिवन टू अस इन द, अब वो कटा हुआ है, फिर वो सेंटेंस के आगे लीड से पहले भी वो डी एक कटा हुआ है, राइट? सो
ये पावर पॉइंट का जरा मसला है, वो मैं देख लेता हूँ।
जी जी, ओके जी, नेक्स्ट।
मैं था नेक्स्ट, स्क्रीन शेयर हो रही है?
Yeah.
So my problem was problem 5, an articulated robot. In problem 5, Martin, a robot, spins a wheel which is divided into an n number of equal sectors numbered from 0 to n minus 1 counterclockwise. The initial starting sector is sector number 0. Martin has several choices to spin the wheel by, including A1, A2, and this goes on till AL. And Martin has a limited number of moves given by K. So in question 1, L is equals L, which is the number of choices Martin has, is equals to 1, and K is at the minimum equal to N. So the question asks us to find the largest number M that Martin can reach. How many moves does it take for Martin to reach this number, and how many different numbers can Martin reach? We will solve this question by finding the answers to all the possibilities presented by the constraints, these constraints in each part, and the total possibilities we get are that n is any number and a1 is equal to 1. The LCM of a1 and n is equals to n, which is also the same as a1 is a factor of n. The LCM of a1 and n is equal to their product. The LCM of a1 and n is not equal to their product. N is any number and a1 is equal to n. So the very first case, n is even and odd and a1 is equal to 1. The maximum possible number that Martin can reach is given by n minus 1, which it can simply just do one clockwise move and it can reach n different numbers, because we know that it has at least an n number of moves. So it can do an entire loop around the wheel. The second possibility, the LCM of A1 and N is equal to N. For example, N is equals to 9 and A1 is equals to 3. The answers in this case are given by M. M is N minus A1. The minimum number of moves needed to reach M is given by N mod A1. And Martin can reach N divided by A1 minus 1 different numbers. The second, the third possibility T is the LCM of A1 and N is equals to N and N multiplied by A1. Some examples of this would be N was equals to 7 and A1 was equals to 3 and N was equals to 5 and A1 was equals to 4. The answers in this case are M is N minus 1. The minimum number of moves needed to reach M is given by N div A1, which is the function div not divide, and Martin can reach N minus 1 different numbers. In the fourth possibility, the LCM of A1 and N, third, the LCM of A1 and N is not equal to A1 multiplied by N. For example, 8 and 6, which have an LCM of 18, which is not equal to 48. In this case, the answer is M is A1 into N div A1. The minimum number of moves needed to reach M is given by N div A1, and Martin can reach the LCM of N and A1 divided by A1 minus 1 different numbers. And the last possibility is N is even or odd and A1 is N. In this case, the answers are M is 0 because it just returns to the starting sector. The number of moves needed to reach M is 0, and Martin can reach 0 different numbers. For values of A1 greater than N, for example, if N is 5 and A1 we can take it as 6. So these lie in an arithmetic progression and which is like modular arithmetic. N is a wraparound case, wraparound number. So in this, for example, N is equals to 6 and A1 is equals to 2. In this case, the answers of A1 is equals to 2, A1 is equals to 8, A1 is equals to 14, and so on would be the same. Or for A1 is equals to 3, it would be 3, 9, and so on. So for question 2 of this problem, it asks us to solve the previous question for any value of L that is less than N. So for question 2, Martin has multiple options to spin the wheel, now not just A1, but we still can use the base combinations. So the LCM and A1 is equals to 1 or N combinations to find the answer. So for example of this method, we can take N is equals to 9, A1 is equals to 3, and A2 is equals to 2. So the answers for A1 is equals to 3, according to part 1 of the question, would be 6, 1, 2 for parts A, B, C, and A2, which is 2, would be 8, 4, 8. So now we can first solve parts A and C. We just need to take the highest individual answer. So in this table, the highest individual answer for part A is 8 and part C is 8. So that gives us our answer for parts A and C. For part B, however, we need to we have two possibilities. One would be using 2 and 3 and then creating 8 from that, from either their addition or subtraction, or it would be, or we could just use the answer for that A2, which already exists, 4. So we can find the number of moves needed to reach 8 using combinations and graphs. So we using that we can find that you cannot create 8 from 2 and 3 with less or even equal than to less than or equal to 4 like combinations, like 2 plus 2 plus 2 plus 2 or 2 plus 2 plus 3 minus 2. So the answer for part B would also come out to 4, which is just our answer for A2. For question 3, it says something is preventing the wheel from turning clockwise, and we have to answer the previous questions 1 and 2 where Martin can only rotate the wheel counterclockwise. So in this question, all values of A1 follow a sort of wave pattern where they always return to zero with at most n number of moves, and then it just loops back. So even if it goes counterclockwise, you can see from this graph here, where the y-axis is the current sector number and x-axis is move number. If it just goes back, it will follow the same shape still. Uh, we can also, in this graph, n is equals to 5 and a1 is equals to 2. So for question 1, if the answer was achieved using counterclockwise turns, which this question doesn't allow, clockwise turns, which this question doesn't allow, then we can just subtract the LCM of n and a1 and the number of turns we originally had. For question 2, however, this it is to be noted that it also limits the number of combinations. So you can't really subtract anymore, you can only add the combinations. Since for subtraction, you need to go in the opposite direction. So originally for 3 and 2 to create 8, the smallest number of moves would be 16, and this was achieved by moving 3 forward and 2 back, 3 forward, 2 back. So in 16 moves, it would reach 8. However, if we're only adding, this number of moves would become 40, which is the same as y, a graph of y is equals to 5x. The wheel has been unlocked, 5x. So for question 4 of this problem, the wheel has been unlocked, but Martin can only, at most do k less than n time n number of moves, but he can now choose the values of a1, a2, al individually. And for part A, the question asks us to consider all possible choices of a1, a2, and then find the maximum number of cells Martin can reach. So for this part, we have a strategy that there is no overlap between each move by the different A1, A2. For example, both A1 and A2 can't reach a certain sector like 1 or 2. If you want to reach 1, you only use one of them. You don't have the option of using both. So with no overlap, the amount of different sectors Martin could reach would be given by L multiplied by K. So over here, L is equals to 2. So we have two options, and K is equals to 2. So we would get, it can reach a total number of 4 cells, which 1, 2, 3, 4. Then for part B, this part, the question asks us to find the smallest number of L, which would allow Martin to reach all possible sectors. So by assuming no overlap and checking different cases such as k is equals to 1, k is equals to 2, k is equals to 3, we arrived at an arithmetic progression for the gap between uh, different choices of A1 and A2. So for example, over here, k is equals to 3 and n is equals to 9. So the gap over here came out to 5, which gave us this equation, not this entire equation, but this fraction for the gap, and then plus 1 for the value 1, because this strategy assumed that a1 was always equals to 1 and then a2 was equals to 1 plus that gap, a3 was equals to 1 plus 2 times that gap, which allows us to reach all possible sectors without having any overlap. That is it for my presentation.
राइट सो अब्दुल्ला, एक तो आपने अभी एक चीज इक्वेशन कहा जबकि वो इनइक्वालिटी है, ठीक है, और दूसरा ये कि आपकी प्रेजेंटेशन में एक दो चीजें हैं जो ज्यूरी को ना आपकी मैथ समझने में मुश्किल पेश करेंगी एंड दे वुडंट लाइक इट। एक तो जब आप कहते हैं n div a1, ये n div a1 का क्या मतलब है?
सर जो फंक्शन div होता है कि आप कितनी दफा डिवाइड कर सकते हो।
ये आपने div फंक्शन कहीं डिफाइन किया है?
नहीं सर, div वैसे एक फंक्शन होता है ना, जैसे मॉड एक फंक्शन है।
बट मैं ये सजेस्ट करूंगा कि div फंक्शन को या तो थोड़ा सा पहले एक लाइन में आप इंट्रोड्यूस कर दें कि div क्या बता रहा है आपको, मतलब वो मतलब 6 div 3 का क्या मतलब होगा?
6 div 3
जी।
2।
इसका मतलब क्या है कि आप कितनी दफा डिवाइड कर सकते हैं, या जो जो मतलब आंसर आएगा, ये आप कहना चाह रहे हैं?
हाँ कि जैसे क्वोशंट में क्या वैल्यू होगी, जैसे मॉड रिमाइंडर देता है ना
नहीं तो
डिवीजन
आप
के बाद।
वो डिवीजन सिंबल क्यों नहीं यूज करना चाह रहे?
ये क्योंकि प्रॉपर डिवाइड नहीं है ना। अ, अगर जैसे हमारे पास आ जाता है 7 div 3, तो उसका आंसर 2 है, लेकिन 7 डिवाइडेड बाय 3 का आंसर 2 नहीं है। क्या है?
मैं ये सजेस्ट करूंगा कि div का ऊपर लिख दें कि इट टेल्स यू द क्वोशंट ओनली, कुछ इस तरह से ना।
अच्छा।
और आपने अभी भी आपके ग्राफ में ना देखिए, जहां आपने 3 दफा शायद ग्राफ दिया, और पहली दफा तो आपने टेक्स्ट में लिख दिया कि एक्स एक्सिस क्या है, वाई
हम्म।
एक्सिस क्या है। लेकिन मैं अभी भी आपको स्ट्रांगली इनकरेज करूंगा, द ज्यूरी विल नॉट लाइक इट। आप लेबल करें ग्राफ को।
सर ये
ग्राफ
मैंने ग्राफ के साथ लेबल करने की कोशिश की थी, लेकिन जो डेस्मोस है ना वो वाई एक्सिस और एक्स एक्सिस के लेबल्स बहुत ऊपर दे रहा था, तो उन्हें स्क्रीनशॉट जैसे करना पॉसिबल नहीं था। और
बहरहाल मैंने आपको एक चीज बता दी है, वो अब आप करें किसी भी तरह से।
ठीक है।
ये लेबलिंग बहुत जरूरी है। आपको पता है लेजेंड भी होता है ग्राफ में। ये
हम्म।
डाटा विजुअलाइजेशन की चीजें, इनमें इनकी बहुत अहमियत होती है। लेबलिंग बहुत जरूरी है। और कम से कम इतनी तो हो, चले लेजेंड ना भी दें, एक्स एक्सिस के नीचे लिखा हुआ हो कि एक्स एक्सिस क्या है, वाई एक्सिस के उस पे लिखा हुआ हो क्या है।
ठीक है सर।
राइट, सो नेक्स्ट जी।
Okay, I'll be starting. Let me share the screen. Can you see my screen?
Yeah.
Okay. So basically, starting from the first part, first I'll be defining the problem. Basically, we need to create a set of possible cocktails in which if we take any two of them cocktails, they satisfy the inequality that do not satisfy the inequality with constraint less than 20, but there is an alternate approach. So basically, there are two approaches. First of all, firstly we can go on finding the total real number values of possible cocktails, then we can find the values that can satisfy the the inequality with less than 20 constant for E naught closed values. But another approach that I find more easier to go about is reversing the inequality sign and directly finding the possible combinations that satisfy this inequality. And for that, as I mentioned last time, first of all, I'll be explaining what the equation, sorry, the inequality means. So for instance, let's take then a cocktail with combinations 99, 0, 1. When I mention these real integers values, they mean the percentage composition of the ingredients. So in this part, we have one milk and two different type of juices. So 99 represents the milk and 0 and 1 respectively represents other two juices. So for the inequality, if we minus the 70 from 99, correspondingly, as they both are the milk, we'll get 29 answer. If we minus 15 from 0 and take an absolute value, we'll get 15, and similarly we'll get 14 for the third component. So the maximum difference of the three corresponding components is 29. So for this
equation, the maximum of the difference will get 29. No matter if we get 15 or 14, still the answer would be 29. That would satisfy the inequality mentioned before, and that would be a possible answer. These two both will be the part of this set. Following this strategy, I have taken out the possible combinations. So basically, there can be different combinations and different combinations starting from depending on from where you start and from where you make mm, the first combination be independent. So in my case, I started from 100 comma 0 comma 0 because I found it easier to go about this way, taking 20 multiples, finding the answers. There can be different ways starting from 99, 98, but the total number of possible value will be still 21. Starting from 100, uh, there would be only a single possibility. Then for 80, there would be two possible values, 63, and similarly going on for 0, we have 6 values. Adding up all these will get 21 possible answers. Okay, so for rechecking, if we take any two of these values in the set, for example, if we take 0, 20, and 80, and 60, 40, and 0, the maximum difference is 60, which also satisfies the inequality that I mentioned before this one. Hence, we can say that all of the values in this set satisfy the inequality, and this set is like right. Okay, so as I mentioned, we can go about other ways as well. For example, if we start from 99, we'll see that again we have to make a minimum difference of 20. We cannot take any value for between 99 and 79 because that would cause the difference to be less than 20 or 20, and that would contradict the requirement of the question. So we need to make sure that we are going with 20 difference. Going on from 99 till 0, again we'll find 21 possible answers. Moving on to the question number 2, there's a slight difference that now we have to add up the differences of these uh, differences between the corresponding values. Again, we have one kind of milk and two different kind of juices, and the question is again, the problem is again the same. We have to find the possible combination that do not satisfy the inequality with sign less than 20. But again, reversing this equation, that it would be more easier to approach. And okay, so defining this particular case, we can have again multiple approaches. We need to make sure that at least the sum of the difference is at least 20. For example, if a naught minus b naught is 7, a1 minus b1 is 7, and a2 minus b2 is 6, then we have 20. But um, an easier approach, what I understood, would be taking 10 as the difference. For instance, I can take a naught minus b naught to be 10, a1 minus b naught to be 10, and a2 minus b2 can be 0 and greater than that, because 0 is always there, and there can be also values greater than 0. So it would definitely always give the value that would satisfy this inequality. Okay, so as I mentioned, that the possible combination would be starting from 100 till 90. Now you be questioning that why there aren't any possibility of an equation lying between 100 and 90. So for that, we'll take epsilon as a small value and make up a combination. So with 90 and 10, if we take 90 plus epsilon as the first part and 10 minus epsilon as the second composition of the juice, and 0 as the third, the sum of these values are 100. And as I mentioned, I'll be starting from 100 comma 0 comma 0. We can see that no value of epsilon would satisfy the inequality. To clarify, let's say epsilon be 4, then we have the combination 94 comma 6 comma 0, and then solving this equation will get 6 plus 6 plus 0, which is 12, and not equal to or greater than 20. Therefore, there are no two values, no other value between 100, 90, and then 90, 80, and then 80, 70. This is the similar pattern that would follow, and the epsilon test was basically to support that. Again, we'll start from 100, then 90, then 80, then 70. There are like many combinations, but I didn't find it like a good thing to like mention all, but I've mentioned a similar pattern. So starting from 100, we'll get one value, 90, two values for 90, four values for 70, and 11 values for the 0, starting from 0. Adding up all these, it would make up 66. Okay. So for the first part of second question, now we need to first define the equation. Okay. So for left hand part of the equation, only define the function value, which is f of x, and then right hand side value represents the maximum difference between components. So for like previously in the last question, they have mentioned like a naught minus b naught, specifically a1 minus b1, but in this question they have been like easier writing x naught x1. So x1 also represents a naught minus b1, and x1 represents uh, a1 minus b1, and so on. So this is that. Um, so first we need to like find the total values that represent the maximum difference to be greater than that epsilon test. Uh, since we need to find an equation for dn of E, we need to first have some specific values to then we can use those values and the equation to generalize the formula. Okay, so first starting from n equals to 2, I will be starting from n equals to 2 because in the first equation, the restriction was 2 and we have already calculated some of the values. And firstly, I will also starting from epsilon equals to 20. And in the first part of the question, we've done this already and we've noticed that there are 21 possible values. Now there's an arithmetic progression starting from 100 onwards till 0, and it will get us the 21 answer. Okay, so for second part, we'll go for E equals to epsilon equals to 20, and n is again 2. As I mentioned in the second part of the question, that I'll be using the constraint 10, not any other possible combination that would help me in this part, because again, they're asking for in this part, we'll be using 10 as the constant, and in the second part of the question, when I've already used 10 as a constant, we'll be writing all the values that I've already written in the last part. This is the arithmetic progression that would proceed. For example, for 100, we'll get one value, for 92, and so on. For 0, we'll get 100 values. Again, it would sum up to 66. So now we'll calculate the values for n equals to 3. We haven't previously find such values, but we'll do it right now. So for n equals to 3, first we'll go about with epsilon equals to 20. So here again, the only change is that the number of ingredients or components. For instance, now there are three different kind of juices and as one kind of milk, and starting from again 100 and again taking 20 as the difference for all of the values because epsilon equals to 20. Okay, so for a combination where 100, 0, 100 and 3 type of zeros are there, there are possible combinations for factorial or 3 factorial which are 4, and for 80 comma 80 80 comma 20 comma 0 will have 12 values. For example, we can replace 0 with 80 and 20 with 0, and we can have different values. For that, I've used this permutation method, and these are the all possible combinations that can have, and we can all swap all the values and get different values. Adding up all these will get 56, which would define that uh, D320 is 56. Now for epsilon equals to 20, we need to go again with the same method of the permutation. For instance, for 100, 0, 0, 0, we have four different combinations, replacing 100 with, on the second place, then third, and then fourth, and also the first. And similarly, for all of the other combinations, we can have total values, and adding up all this will get 286. And then we can state that G3 of the 10 is 286. So basically finding all of these different values, taking n and epsilon, is the part of like then generalizing the equation for dn of E. So basically, for instance, to clarify, I'll mention that for the first part where the value of n was 2, we can use an arithmetic progression formula like n into n plus 1 over 2, and solving up will get 100 plus epsilon times 100 plus 2 times epsilon and over 2 epsilon power 2. And for D3, we can follow the similar pattern that we used in previously. for that we can add up another equation of 100 plus 3 epsilon, and in the denominator we can change the coefficient and the power. But there is an twist that following the equation, if we put in the values of uh, value of 20 and 10 in the equation for n equals to 3, we'll get the values double, which means that there needs to be another um, another 2 in the denominator, and for that we can generalize again once, and for that I've added factorial, which doesn't make the difference in the n equals to 2 equation, but would make a difference in the n equals to 3 equation, and hence we can generalize the equation, and this way the bold equation will be the final equation, and that's all.
अच्छा हाशिम, आपकी प्रेजेंटेशन में भी ना एक दो चीजें हैं जो ज्यूरी को पुट ऑफ करेंगी। एक तो ये है कि सब्सक्रिप्ट्स का बहुत इशू है।
जी सर, वो मैं कर लूंगा अभी, एक्चुअली आई वाज वर्किंग
हाँ,
ऑन दिस
क्योंकि आपने देखा है कि आपकी प्रेजेंटेशन में हैं भी ज्यादा सब्सक्रिप्ट्स बाकियों की निस्बत,
जी
तो
सर।
वो बहुत बड़ा कंसर्न है, वो बहुत जरूरी है ठीक करना, अब तक हो जाना चाहिए था। अच्छा, दूसरा सीरियस कंसर्न ये है कि आपका जो ये टेम्पलेट है, इसमें शायद इस तरह से है कि हेडिंग में आप कैपिटल में करते हैं सब कुछ और टेक्स्ट में वो स्मॉल में होता है। ये भी बहुत डेंजरस है, बहुत ज्यादा डेंजरस है कि वो हेडिंग में आपके x0, x1, x2 कैपिटल में आ रहे हैं और मेन टेक्स्ट में वो स्मॉल में चल रहे हैं। फिर आपका मैक्स फंक्शन जो है वो मतलब कैपिटल मैक्स है हेडिंग में, स्मॉल मैक्स है टेक्स्ट में, f ऑफ x है वो कैपिटल F है हेडिंग में, स्मॉल f। ये बहुत इनकंसिस्टेंट है।
ओके सर, वो मैं ठीक करता हूँ।
ठीक है, आपको पता ही है कि मैथ्स में ये सारा कंसिस्टेंट होता है। देखने वाले असल में जो मैथ्स का माइंड होगा ना, जो ज्यूरी होगी मैथमेटिशियन की, वो ये समझेगा कि कैपिटल मैक्स कोई और फंक्शन है, स्मॉल मैक्स कोई और फंक्शन है। यू नो, हमारे माइंड्स उतना ट्रेन हो चुके होते हैं।
Sir, I had one comment to make as well, if I can.
जी प्लीज।
The presentation was way longer than 10 minutes. I think it was like 15, 16 minutes. So maybe just like reduce the time thoda sa.
या
So, Reham, are we done?
Sir, no, Abdullah is left.
Oh yes, Abdullah Gondal Saab.
Yeah.
Sir, is my screen visible?
Yeah.
Yes, so basically problem 4. So the problem, this game belongs to a class of impartial games, and we have used a combination of combinatorial game theory as well as Pre-Grundy theorem to tackle this problem. This is just a problem. Let A, B, and N be positive integers. Alicia and Benjamin are playing a game on an A times B rectangle. So they've given us an A times B board, and Alicia and Benjamin take turns playing on this board. They alternately place polynomials of different sizes throughout the game. There are different variations of the game, and we'll tackle all the variations of the game. So we'll start off just with some simple definitions of impartial games. Impartial game is a two-player game in which players take turns to make moves, and where the moves available from a given position only depend upon which player's turn it is to move. So the moves are not specific unless chess. You are unlike chess, in which you have your set of moves specific, either black or white. Impartial games don't have such specific moves. There are just common moves. Every player can make the same set of moves from a certain position. And the definition of player 1 and player 2, we define a player 1 as a person who chooses where the first polynomial on the rectangle will be placed, and similarly player 2 will be the one who chooses where the second polynomial on the rectangle will be placed. There's two types of impartial games. There are two types of plays in impartial games: normal play and miser play. The player to make the last move in a game wins. This is called normal play, and the one to make the last move loses. And this type of play is called miser play. And this, whether the game is in normal play or miser play, it is just indicated by the rules of the specific game. It is specific to the rules of the game. If the game rules can indicate whether the game is in normal play or miser play. It is not some fixed thing. So how to tackle it? First, we say that to tackle impartial games, we first convert them into directed acyclic graphs. And when we convert it into directed acyclic graphs, we see that eventually in directed acyclic graphs, they will always reach such a position from which no further moves are possible, such as this and this. We call them as terminal positions. We'll specifically define them for as well. So we just say that we represent the game on a graph, and we define that graph as G is equal to X and F, where X is just the set of all possible game positions, and F is a function that gives for each X which belongs to capital X a subset of possible X's to move to, called followers. For example, it tells us about the moves possible from a certain game position. We'll look into it again later on. And here there are two following types of game positions in impartial games: P position, N position. A game is in P position if it secures a win for the previous player. Likewise, N position, a game is in N position if it secures a win for the next player, and a terminal position, like I said, from which no further moves are possible, we define it as a terminal position. So we can say that in normal play, we can say that every terminal position is also P position because it secures a win for the previous player. Now, towards backwards induction, it is a process which we use to calculate the Grundy values of a game. These are just the steps involved with label terminal position as P position. Like I said, every terminal position is P position, and every position that can reach a P position will be an N position. So we just label the different game positions and we get it. So the Sprague-Grundy function, this is a function of a graph G is equal to XF, which I explained earlier. And what it does is that it gives the minimum excludent in a set, the value of the minimum excludent in a set. For example, if we have a set of 0, 1, 2, then the minimum excludent of them will be 3. I don't know why it's not appearing here. ये syntax का issue होना नहीं चाहिए, मैंने सारा सही किया था वैसे. So the max of likewise the max of 0, 1, and 3 will be 2. It is the Sprague-Grundy function gives the minimum excludent of the set. So the minimum value not present in the set is in 0, 1, 3 it is 2, and this value has to be non-negative, right? So the minimum non-negative integer value not present in a set, that will be the max function, and this value we call it Sprague-Grundy function, which gives us. So now calculating Grundy values. On acyclic graphs, we just represent the game on a set, on a graph, sorry. We represent the game on a graph, and then we calculate the Grundy values. A terminal position is set as 0, and such a position which reaches 0 is 1, since, the max of 0 will be 1. Likewise, the max of 1 and 2 will be 0. So this position, even though it's not terminal, its Grundy value will still be 0. And now number arithmetic. The key operation in the solution to these impartial games is number arithmetic. We calculate the Grundy values of independent subgames and then we XOR them. This is just a XOR, or we can say the exclusive OR of the two numbers. What we do is that we write the denary numbers into binary, and we bitwise we take the XOR of them. For example, if there are even number of for example, if there are an even number of ones, it will give us 0, and if there are odd number of ones, the answer will be 1. So we have odd numbers here, hence we write 1, 1, 1. We interpret this as denary, which gives us 7, and we can say that the XOR of 3 and 5 is 7. Although if we look at it in simple terms of simple addition, it is 8. But when we say that the XOR of 5 and 3, it will be 7. It will not be 8. So because we take the this function, according to this XOR function, we take the exclusive XOR of the numbers bit by bit. And so the nim sum is defined as an exclusive XOR operation applied to the Grundy values of the components of game. I've already explained it. Okay, what is nim sum? We calculate it by, so these are just our, for example, these are our Grundy numbers. We XOR them, and this value, this will be the nim sum, like here. And nim sum is defined as the exclusive XOR operation applied to the Grundy values of the components of a game. And what is the component of a game? It is just an interesting aspect. A component of a game is defined as an independent, smaller subgame within a game. A smaller independent subgame. So when we talk about an empty A times B rectangle, there will be no independent subgames within it, right? So we'll say that it contains only one game, no independent subgames. So in that case, the Grundy value we get for that game position, we will not XOR with it with another subgames, because there is no other subgame. We will XOR it with 0. I've just explained this text. So the nim sum for that game will just be its Grundy number, since any number XOR'd with *0 is a number itself. So here we will just, these are just some simple mathematical proofs. We prove that the winning strategy normal plays to finish every move with a nim sum of 0. How? We've explained it as here. Let S be the nim sum, the XOR operation applied to the Grundy values x1, x2, and T the nim sum after a move has been made. So this how I was proved it. It's just because of some basic function, characteristic of XOR operation. Anything XOR'd with itself will be 0. S XOR'd with itself will be 0. And again, anything like XOR'd with 0 will be that thing itself. Like for example, T XOR'd with 0 will be T itself, as I've explained earlier. So we use those simple characteristics and expand it, and then we arrange them together to get to the conclusion. This T, the nim sum after a move has been made. If S is 0, then T must be non-zero, since XK XOR'd with YK will never be 0. And again, if it is always possible to make the nim sum 0 on your turn, if it wasn't already 0 at the beginning of your turn. So for example, if a player has to make a move, and the game and the Grundy value, or the the nim sum for that game position is non-zero, then that player can always turn the nim sum to 0. I've just simple characteristics of XOR operation to explain this as well here. So what that player, this just defines the move that specific player has to make to reach a nim sum of 0. And here is the winning strategy. I have just summarized the previous two, lemma 1 and lemma 2. If you start off by making your first move so that the nim sum is 0, then on each turn your opponent will turn the sum to non-zero. You will in turn set it back to 0. By lemma 1, the opponent has no choice but to disturb the sum, and by lemma 2, you can always set it back to 0. Eventually, on your opponent's turn, there will be no further moves possible, and you are the winner. Alice needs to deploy the same strategy here. Alicia needs to deploy the same strategy here. So now, yes, for the specific. So this is just a graphical representation of what we need to do to get to the nim sum. We convert the game on a graph, to a graph. A directed acyclic graph will be formed. We calculate the Grundy values using backwards induction. We XOR the Grundy values. We get the nim sum, and then we can check if that specific game position or that specific board is an Elijah win or Benjamin win. Here I've just explained the practical strategy and the same thing. Elijah will win on all A times B rectangles for which the Grundy number is non-zero initially by turning the nim sum to 0 on each of her turns. And just practically every even X odd empty cram board, cram is the game when n polynomial size is equal to 2. So has a winning strategy for Alice, as all even X odd empty cram boards will always have a Grundy value equal to 1 or greater than 1, and on every even X even board she will always lose. As for odd boards, there is no general solution to those. We need to determine the winning strategy on a case-by-case basis. But one thing is clear, that Alice will win on all those odd rectangles for which the nim sum is non-zero initially. So to solve a example case, last time sir asked me to solve some example cases as well. I've solved it here 2 times 3 rectangle, and n is equal to 2. So these are just a set of all possible game positions you can reach from this game. Then again, from this, independently from all game positions, all possible game positions you can reach, we label the terminal nodes as 0, 0 here, and 0 here, and then we do backwards induction, and then we calculate the Grundy value of this game, which is *1, and it is non-zero. Hence, Alice will win on this 2 times 3 board. The solution to part B and C is the same. Even if you increase the polynomial size, Alice will win whenever the name sum is non-zero initially. So now, let us modify the game and allow Elijah and Benjamin to choose any polynomial of size 1 to n. And here, in this case, all cases, Elijah will always win because she is the one placing the first polynomial, and she can simply choose to place a polynomial of a times b size and cover the entire rectangle, leaving no spaces for Benjamin, and winning, leading to a terminal position. So the Grundy value for such a game will be *1 is equal to *0, because one move can turn the can lead the game into a terminal position. And part 3, winning strategy for miser play. So now in this case, although the polynomial being placed first is Alicia's polynomial, but the one placing it, choosing where it is being placed, it is Benjamin. So Benjamin will be player 1, Alicia will be player 2, and again we use the same strategy here. The nim sum, there, like we have answers for case by case basis. When the nim sum is 0 initially, Benjamin will always win by choosing such a polynomial that turns the nim sum to non-zero. So in this case, facing a terminal position is, like a good move, an optimal move. Every player wants to reach to face such a move, to face such a game position which has 0 Grundy value. And likewise but we have 2 separate cases when the name sum is non-zero initially, unlike normal play. In normal play, we do not have separate cases for them. When the name sum is non-zero initially and consists of a terminal position only, player 1 will lose because he can only make one move that turns the nim sum to 0. And as I said, facing a 0 position is a optimal is a good, it's a good move, good position to be faced with. So player 2 will face *0 and he will win. But when the nim sum is non-zero initially but consists of terminal position and another non-zero position, then player 1, in this case Benjamin, can still win by making such a move that the nim sum remains non-zero, by choosing such a move that the nim sum does not move to 0, remains non-zero, because the game is not balanced when the nim sum is non-zero, and from one non-balanced position you can go to another non-balanced position. Unlike the normal play strategy, when the game is balanced in at terminal, when the nim sum is 0, from a balanced position you can only go to another non-balanced position. And again, part 4, additional directions of research, the last part of this problem. We have so in all the 3 parts we have determined Grundy values and nim sums for empty A times B boards, but we can use the same approach to calculate Grundy values for partially filled boards. Likewise here, when n is equal to 4 and a game has been partially played, so we calculate the Grundy values for individual subgames 1, 1, and 2, as I mentioned earlier in the proof. We XOR the XOR function, we apply that function, we get 2. It is non-zero, hence we can say that whoever places the first polynomial on this partially filled A times B board, he or she will always win, considering that the game is being played in normal play. Thank you. That's it.
अच्छा, अब्दुल्ला, आपका भी एक तो स्लाइड 22 जो थी आखिरी, अभी शेयर रखें स्क्रीन। स्लाइड 22 में आपके ये इन्वर्टेड कॉमास हैं लास्ट पैराग्राफ में, वो गलत हैं। आपकी स्क्रीन नजर नहीं आ रही। चले, मैं वैसे आपको बताऊं, स्लाइड 22 में आपके इन्वर्टेड कॉमास जो है वो आखिर में वो गलत हैं।
जी सर, मैं स्क्रीन देख लेता हूँ पूरा।
क्लोजिंग वाले ठीक है, ओपनिंग वाले वो फिर से क्लोजिंग वाले हैं।
सर मैं 1 सेकंड में दोबारा शेयर करूँगा, प्लीज दोबारा बता दें।
जी, अब नजर आ रहा है स्लाइड 22 पे ना। अच्छा, स्लाइड 16 पे रुके।
जी सर।
अच्छा, ये जो
15 और
हेडिंग
16।
है, स्टेप्स फॉर कैलकुलेटिंग निम सम एंड नोइंग विच प्लेयर एन इम्पार्शियल गेम, इसका क्या मतलब है?
सर ये मतलब टाइपिंग एरर मैं भी बना रहा था, ये एड की मैंने, मैं
काफी सारे
ये तो
टाइपिंग है ना, एक तो नहीं, जुमला ही नहीं समझ आ रहा। एंड
सर
नोइंग विच प्लेयर,
स्टेप्स फॉर कैलकुलेटिंग नेम सम एंड नोइंग विच प्लेयर विच, सर ये आगे से रिमूव हुआ, विच प्लेयर
हाँ ये
कैन
बहुत
विन
जरूरी
एन
है
इम्पार्शियल गेम, ये यहाँ पे सी
हाँ,
था।
इसको ठीक करेंगे आप। और वो स्लाइड 22 पे जो मैं बता रहा हूँ कि वो आपका
जी सर।
इन्वर्टेड कॉमास लास्ट पैराग्राफ में, ठीक है, ये भी है
सर
मसला।
ये
फिर
जी सर, सही समझ आ गया।
हाँ, फिर आपने देख ही लिया कि कुछ जगह आपके बॉक्सेस आ रहे हैं, सिंबल्स नहीं आ रहे आपके।
सर ये वैसे, लेकिन सर यहाँ पे तो सही आ रहा है ना, तो वो पता नहीं उस पेज में दोबारा इसको देख लेता हूँ, ये तो फॉर्मेटिंग का एरर है
मतलब जरूरी चीज है ना
सिर्फ।
ये सब, मतलब बैड
जी जी सर,
इंप्रेशन है ना
बिल्कुल।
आपका।
जी सर बिल्कुल, मैं
और
इसको दोबारा
अच्छा,
देख लेता हूँ, ये
जो फिर
हालांकि
आप
मैंने
लोग
सारा।
सारे जो एक काम आप लोग कर रहे हैं ना, असल में यही फायदा है लेटेक्स का कि इट टेक्स केयर ऑफ इट, वो खुद ही से वो उसका रख लेता है ख्याल। देखिए मैथ्स में वेरिएबल्स जो हैं वो इटैलिक्स में होते हैं। अब
जी सर।
ये पावर पॉइंट पे मसला है, ये आप सब की प्रेजेंटेशंस में, काफी सारों की प्रेजेंटेशंस में, कि वेरिएबल्स इटैलिक्स में होते हैं, लेकिन जो मैथ्स के सिंबल्स हैं, जैसे अगर a टाइम्स b है तो वो
जी सर।
टाइम्स का सिंबल इटैलिक्स में नहीं होगा, लेकिन a और b इटैलिक्स में होंगे। तो ये चीजें जो मैथमेटिकल आई होती है ना, उसको थोड़ा स्ट्राइक करती हैं ये चीजें।
जी
तो
सर, मैं
आप
फिर
सबके लिए
सर मैं
अभी
फिर
आपके
इन जो X1 X2 ये सारे इनको इटैलिक्स में करूँ या इनको ना करूँ? इनको वैसे मैंने सब्सिट्यूट में तो लिखा है अभी।
असली तौर पे ये इटैलिक्स में होने चाहिए।
ठीक है सर, मैं कर लेता हूँ इसको भी, और A टाइम्स B को भी सर।
अ, बाकी आप चूंकि कल के लिए आप लोगों के लिए, सबके लिए रिकमेंडेशन मेरा यही सजेशन है कि अ, कल आप लोग इस पे फोकस करें कि जो काम कर चुके हैं उसी को पॉलिश करें, रिफाइन करें, परफेक्ट करें, बजाय इसके कि नए पार्ट्स अटेम्प्ट करें। कल चूंकि लास्ट डे है, टाइम इन्वेस्ट करें, एफर्ट लगा दें, थोड़ा प्रायोरिटी करें, कल के रूटीन कामों को थोड़ा आगे पुश कर दें। और इसको जो है, लेकिन जो नए पार्ट्स पे ना टाइम लगाएं।
सर
जो
मेरे इस प्रॉब्लम के 4 पार्ट्स ही हैं खाली, 4
जी,
मैंने
मैं
सारे
वैसे
अटेम्प्ट किए हैं।
मैं सबके लिए कह रहा हूँ कि जिनके
जी
जैसे
जी
रैक
सर।
है, तो जो पुराने पार्ट्स ही हैं उन्हीं को जो मतलब काम कर चुके हैं उसको रिफाइन करें, अपना कंसेप्ट और इंक्रीज करें कि जैसे हम कल रेहाम से बात कर रहे थे, उसमें रोटेशनल मैट्रिसेस हैं, ये वो चीजें हैं, तो उनको थोड़ा और अंडरस्टैंड कर लें कि आपसे कभी पूछ लिया जाए। जाहिर सी बात है, इस तरह वन वे प्रेजेंटेशंस तो नहीं होंगी, आपसे क्वेश्चनिंग भी होगी। तो आप
जी सर।
जितना कोई ऐसी चीज ना हो जिसको आप आंसर डिटेल में ना कर सकें। तो मेरा ये सजेशन है कल के लिए। और
और सर
रेहाम
एक मैंने,
भी।
सर आपसे एक चीज पूछनी थी सर। आपने लास्ट टाइम मुझे कहा था कि एग्जांपल केसेस बना लो, तो सर ये एक तो मैंने ये इस तरह बनाया है, तो इसी फॉर्मेट पे मैं और भी मतलब और टाइम्स ऑड के लिए और n = 3 के लिए भी बना दूं, या मतलब आपसे पूछना था, इस
जी
तरह सही है?
हाँ, आपका काम इस तरह का है कि उसमें एक तो एग्जाम्पल्स होनी चाहिए, प्लस इस तरह की पिक्चर्स होनी चाहिए, डायग्राम्स होनी चाहिए ना।
सर ये
तो
इस तरह सही होगा ना सर,
विजुअलाइजेशन से,
जो ग्राफ मैंने
हाँ
बनाया
ये
है,
वाली
इज इट
अच्छी थी,
ऑलराइट?
इनफैक्ट मैं यही नोटिस कर रहा था कि कम है, अगर और इस तरह की हो तो आपकी ये प्रेजेंटेशन ज्यादा
जी
खूबसूरत
सर,
हो
मैं
जाए।
ओके सर, मैं और भी इंक्लूड कर लूंगा।
तो
वैसे I just wanted to add one thing. सर सज्जाद ने मुझे ओवरलीफ पे जो है एक टेम्पलेट भेजा था जिसपे ही प्रेजेंटेशन बन जाती थी। जो मैंने प्रेजेंट किया था वो मेरा लेटेक्स पे ही था, बट वो ओवरलीफ पे बना था और वो प्रेजेंटेशन के फॉर्म में बना था। सो इफ यू गाइस वांट मैं वो भी फॉरवर्ड कर सकती हूँ ताकि वही सब इस्तेमाल कर लें, ताकि सबका एक ही टेम्पलेट हो क्वेश्चंस का। ये सब हम लोग एक ही टीम है टेक्निकली।
बिल्कुल आप लोग बिल्कुल आप शेयर करें। और रेहाम, आपको मैंने यही कहना था कल के लिए, एक तो जैसे मैंने कहा कि बजाय ये कि नए पार्ट्स पे टाइम लगाएं, अपने पुराने काम को ही फाइनल करें। और रेहाम, कल फिर आप ही एक डेडलाइन का बहुत ख्याल रखना है, बिल्कुल लास्ट मोमेंट पे नहीं करना, क्योंकि नूर के भी जो है ना वो भी यूनिवर्सिटी स्टूडेंट है, उनके भी एग्जाम्स चल रहे हैं आजकल, तो उनको ज़्यादा हम नहीं बॉदर करेंगे। तो आप रेहाम, आप चूंकि कैप्टन हैं, एक सबके साथ कोऑर्डिनेट कर लें और कोई भी टाइम मतलब बहुत ज़्यादा लेट ना करिएगा। कल की जो डेडलाइन है तो उसमें आप लोग सारे मिल के एक टाइम डिसाइड कर लें और उस पे जो है अपने काम को फाइनल करके नूर को भेज देना।
Yeah. So I think tomorrow's deadline, let's keep it 8 p.m., 8:30 maximum.
मैं तभी देखें आप पे छोड़ रहा हूँ, आप लोगों की टीम है, सो उसको अच्छी तरह फाइनलाइज करें, और ये कि जैसे मैंने कहा हमने देखें तभी ये थोड़ा सा डेट्स इस तरह से रखी हैं। अब देखें सज्जाद बीमार हो गए हैं, तो ये चीजें मतलब हो जाती हैं नेचुरल, कुछ आ जाती हैं डिस्टरबेंसेस। तो अब कल इंशाल्लाह हमारे पास जब काम पहुंच जाएगा तो फिर कुछ हमारे पास दिन होंगे सज्जाद और मेरे पास के हम उसको थोड़ा सा रिव्यू कर लेंगे। तो ये बहुत जरूरी है कि कल की डेडलाइन मीट हो। तो ये अब आप कैप्टन है तो ये अब आपके ऊपर हो गया।
सर मेरे पास एक सवाल था।
जी
कल
जी।
डेडलाइन में हमने सिर्फ ओवरलीव डॉक्यूमेंट सबमिट करवानी है या स्लाइड्स भी?
ये वैसे बेहतर है कि नूर से पूछ लें, ग्रुप ग्रुप पे पूछ लें, नूर फिर रिस्पॉन्ड कर देंगी।
ठीक है सर।
मेरा सिर्फ उसमें पॉइंट ये है कि देखें जैसे मैंने पहले भी कहा था ना, असल तो ये है ना कि असल तो आपका जो नॉलेज है वो ज्यादा कंटेन करता है आपके ओवरलीव डॉक्यूमेंट, उसको रिफ्लेक्ट कर रहा होता है कि यार इनको इतना कुछ आता है, इतना इन्होंने सॉल्व किया है। प्रेजेंटेशन तो वो वाली चीज है ना कि प्रेजेंटेशन में तो अब आपने लिखा है लेकिन फिर उसमें जाहिर सी बात है वो कोई गारंटी नहीं है कि आपने विदाउट प्रूफ कोई चीज लिख दी है। तो वो फिर तो ये, लेकिन आपका सवाल तभी मैं इसमें नहीं आंसर करूंगा, ये फिर नूर ही बेहतर आंसर कर सकती हैं। तो रेहाम फिर आज का, अच्छा शहरबानो ने मुझे कुछ बताया था, उनका एक्सक्यूज था। तो लेकिन बस यही होता है कि कोशिश करनी चाहिए कि मैनेज करें चीज़ों को साथ साथ। मैं भी इनफैक्ट जैसे मैंने शुरू में बताया था, अभी मैं मतलब अपने घर में नहीं हूँ, मैं कहीं बाहर से ही अटेंड कर रहा हूँ। तो लेकिन चलें तो रेहाम फिर हम कंक्लूड करें इसको।
Yeah, sir, I think everyone did pretty well today. So I think we're done for today now.
राइट, सो कल का काम आपके फिर जिम्मे है। आई विल
Yes, sir.
रेस्ट अश्योर्ड कि कोई इशू नहीं आएगा और नूर तक जो है स्मूथली आप लोगों का काम पहुंच
Yes.
जाएगा।
Yeah, hopefully, sir. I'll make
सो
sure that.
आप सबको बेस्ट ऑफ लक, और प्लीज कल का दिन जो है जरूर इन्वेस्ट करें, और जैसे मैंने कहा कि अपने पुराने काम जो कर चुके हैं उसी को और रिफाइन करें, और जितना उसके पीछे बैकग्राउंड नॉलेज है उसको और स्ट्रॉन्ग करें। सो ठीक है, फिर एंड करते हैं इसको, मीटिंग को।
Okay, sir. Allah Hafiz.
ऑल राइट, अल्लाह हाफिज।
Allah Hafiz.